So hello everyone, welcome to Geophysics Academy. UPSC कंबाइंड जियो साइंटिस्ट का जो एग्ज़ाम था, ठीक है, उसका आई होप अब लोग सब लोगों का प्रीलिम्स का एग्ज़ाम अच्छा हुआ है। जो स्टूडेंट का प्रीलिम्स का एग्ज़ाम अच्छा हुआ है वो लोग शायद मेंस के लिए भी तैयार होने के लिए आप लोग तैयार हो रही हो, ठीक है। तो मेंस का सिलेबस थोड़ा बहुत है, तो उसको आपको अच्छे से एक टू द पॉइंट फॉर्म में आपको वन बाई वन आपको पढ़ना होगा, ठीक है। तो इसलिए मैंने जितना हो सके मैं कोशिश कर रहा हूँ वीकली एक वीक में 2 डेज़ वीडियो देने के लिए। तो इससे थोड़ा बहुत आपका थोड़ा जो कंसेप्ट है वो क्लियर हो जाए, यही मेरा एक्चुअली आशा है। ओके, सो बेसिकली I'm already upload one videos for solid earth geophysics, and this video is actually based on the primary wave, that is P wave, one kind of seismic wave. And in details I will discuss what is primary wave and what is the primary wave velocity and its in primary wave amplitude, how decreases and etc. Okay, and now in this today's video I will discuss here the S wave velocity or transverse velocity. Why S wave velocity and why transverse wave is called S wave velocity? That's type of questions we are discuss here. And what is the exact formula of velocity of S wave, and now and the comparisons between S wave and P wave, and also the classifications of S wave, etc. in this video I will discuss here. Okay, so let's start our video. So now, as usual, I am Mithun Patro. I am actually working in I am a PhD scholar at NISES Bhubaneswar at ACPS, and I am actually working in exoplanetary atmosphere and theoretical studies. So okay, now let's start our video. That is actually lecture 2. Okay, lecture 2 of solid earth geophysics. Lecture 2 of solid earth geophysics. Okay, so now we already know the seismic wave have there are two kinds of seismic, mainly two kinds of seismic waves, S wave and P wave, based on the propagations. Actually the seismic classifications of seismic wave based on the propagations, right, based on the propagation styles. These waves are propagating in parallel to the wavefront or perpendicular to the wavefront. That depends on these configurations we are classify this S waves actually. Okay, so this is another S wave is equals to transverse wave. Another seismic wave is called transverse wave. Transverse wave, or it is called S wave. We are discussing here why it is called S wave or transverse wave or S wave. Okay, or secondary wave. Why it is called S wave? We are discuss today. Okay, so when a seismic wave are created by a seismic source at a particular point where actually earthquake occurs, then this kinds of wave how propagating through a medium. Okay, so this transverse wave is actually propagating in a medium, right. इसका जो मीडियम के थ्रू प्रोपागेट करने का तरीका वो एक्चुअली क्या है, ये आपको जानना चाहिए, राइट, ये आपको जानना चाहिए. सो लेट अस कंसीडर ए पिक्टोरिकल व्यू, राइट, लेट अस कंसीडर ए पिक्टोरिकल व्यू. Okay, let us consider a pictorial view how this transverse wave is actually propagating through a medium. Now it's a divided some block for understanding purpose. We just make some block. Okay, and this is the force actually acting on this section, right. and the direction of propagations, and this is the directions of propagations of seismic wave. Directions of propagations. Okay, so actually what happened in transverse wave? You already know for longitudinal wave, the waves are propagating in the direction of propagation. But in the case of transverse wave, what happened actually? Right. So in the case of transverse wave motions, uh, what happened? These are the vertical plane, right? These are the vertical plane, right? These are the vertical planes. These also are the vertical plane. These all are the vertical plane. These all are the vertical plane. Okay. These all are vertical plane, right? These all are vertical plane. So these all vertical planes are actually uh, move up and down. Okay, so when transverse wave propagating through mediums, and uh, we consider the medium have a some vertical plane, right? Vertical plane. So when this seismic waves is propagating through mediums, then the vertical plane move up and down, and the corresponding adjacent element of the medium experience shape distortions, right? Shape distortions, and the shape is actually changed rapidly from rectangle to parallelogram and parallelogram to rectangle. Okay, so it means the adjacent element of the medium suffer a vertical shear, right? So what happened? So basically when a transverse wave propagating through a medium, then the medium suffer a vertical shear, right? Okay, so here get, so transverse wave when propagating through a medium, then the medium element of the medium suffer vertical suffer. How? Because the vertical plane of the medium move up and down, and the adjacent element of the medium experience shape distortions. How shape distortion actually occurs? The shape distortion is like that, the changing of the shape from parallelogram to rectangle to parallelogram, and parallelogram to rectangle. It's like that. Okay, so this is the main fundamental theory when transverse wave propagating through a medium. So okay, first of all, right here the what is the case actually occurs. So what happened here? What actually happens? The rectangle, this rectangle vertical plane have some distortions. What kind of distortions actually occurs? It's actually occurs like that. It's actually occurs like that. Okay, it's actually occurs like that. Okay, this kind of shape distortions actually occurs, right? This kind of shape distortions is actually occurs here. This kind of shape distortions. This is the shape distortions. This kind of shape distortions is actually occurs. Okay, this shape distortions is occurs. This shape distortions is actually occur due to the vertical shear, right? This is the vertical shear. So we actually along these directions have vertical shear. Vertical shear. Okay. So this is actually scenario when a transverse wave propagating through medium, right? Okay, let's write down the concept. So when transverse wave propagating through medium then the vertical plane moves up and down. Okay, up and down, and adjacent element of the medium experience shape distortions. Okay, shape distortion. Shape distortions. Okay, and like a rectangle to a parallelogram, and back. Okay, so it means elements of the medium suffer vertical shear. Okay, that is very important point. So basically when transverse wave propagating through a medium, then the elements of the medium suffer vertical shear. That is important points. So now so due to this vertical shear, okay, due to this vertical shear, so this how this vertical shear is actually acting on a one particular vertical plane. We will just look for that. Now let us consider how this vertical shear is actually acting on a particular vertical plane, particular parallelogram, right? Particular parallelogram. Okay. So now just this is the principle. So based on this vertical shear, okay, this is the force actually acting on this one parallelogram along the vertical directions. Based on this concept, ठीक है, जो concept है इस concept के ऊपर based करके हम लोग जो transverse wave है, ठीक है, उस transverse wave का हम लोग velocity calculate करने वाले. Actually we are calculate the velocity of this shear wave actually. Then we calculate, for transverse motions, transverse wave velocity is always called shear wave velocity. Yes, actually we know that. So based, now we use these principles actually here. Now we use the principle. So now we consider the now we calculate the velocity of S. Now let us calculate the. So this is the principle. Okay, based on this principle, using this principle, ठीक है, ये जो प्रिंसिपल हम लोग ऑलरेडी मेंशंस किया, इस प्रिंसिपल इसी प्रिंसिपल को हम लोग यूज करेंगे और इसी प्रिंसिपल को यूज करके हम लोग आगे थ्योरी को डेवलप करने वाले हैं, राइट। ये जो थ्योरी हम लोग नेक्स्ट डिस्कस करेंगे वो एक्चुअली वेलोसिटी रिलेटेड, हम लोग कैसे उसका वेलोसिटी को कैलकुलेट करते हैं वो हम लोग रिलेट करने वाले हैं। एस वेव का जो वेलोसिटी है वही हम लोग कैलकुलेट करेंगे, ठीक है। इस प्रिंसिपल के ऊपर पे जो प्रिंसिपल हम लोग डिस्कस किया अभी, इसी प्रिंसिपल को हम लोग फॉलो करने वाले हैं, राइट। सो नाउ लेट्स टेक ए हेडिंग वेलोसिटी ऑफ एस वेव, कैलकुलेशंस ऑफ velocity of S wave. So to calculate the velocity of S wave, first of all we consider the distortion of elementary boundary by vertical plane. Okay, so we consider a small vertical plane and consider the distortions of a. So to calculate the velocity of S wave, first of all we consider the distortion. Consider the distortion of an element. Okay, bounded, that is actually bounded by vertical planes. Okay, bounded by vertical planes. This is the consider. First of all, you consider that. Now take a pictorial view. Now let us take a pictorial view how this is actually occurs. Okay, this is the x-axis. This is the x-axis and this is the z-axis. Okay, and we consider a parallelogram here. सॉरी, इस पिक्चर को अच्छे से ड्रॉ करना पड़ेगा, नहीं तो समझ नहीं आएगा। या आई थिंक इज ओके। Okay, I think it's okay. This is the concept of parallelogram. Okay, right. This is the consider the a parallelogram, and this portion and this portions are placed along the x-axis at a positions x and x plus dx. Okay, and the area of this surface is equals to ax. Okay, area of this surface is equals to ax, and this is the actually displacement along vertical direction. Okay, due to transverse wave. This is the actual displacement. Okay, this concept displacement is along the vertical direction is w, and at x equals to x plus dx I have a displacement omega plus d omega. Okay, this is the displacement. Why it is displacement occurs along the vertical directions acting some force, vertical shear or vertical shear. So at this surface, okay, at this surface along the vertical directions acting a force Fz, and also at this surface acting a vertical direction, vertical shear is equals to f of z df of z. Okay, so due to vertical shear we have a displacement along the vertical directions of the vertical plane in the medium, right? This is the actual phenomena. So here we just call, so let us consider when the passage of wave, when the passage of wave, okay, in the x direction, so direction of propagations, right? In the x directions, this is the directions of propagations. X directions. So when the passage of wave in the x directions, propagate, okay, produce displacement, produced a displacement W and a force, right? Wave propagating in x directions produced a displacement W and a force, obviously force, along vertical directions Fz in the z directions, okay, in the z directions, right? At the position x. Similarly, okay, so okay, at the positions at x equals to x, this wave, transverse wave, okay, when propagating in the x directions, produced a displacement of the vertical plane. This is the displacement of the vertical plane and the vertical shear along the z directions at x equals to at a position x, okay. Similarly, at the position x plus dx, okay, at the positions x plus dx, have the displacement omega plus d omega and the force Fz plus dfz. So what is the mean actually? So at a positions x, due to the wave, when this wave is propagating in a x directions, and this wave produce the displacement of the vertical plane along the z direction is w, and it produce a force vertical, that is called vertical shear, that is called Fz in the z direction also. at a similar positions at another positions x plus dx. Okay, have displacement omega plus d omega and a force fz plus dfz. What is the mean actually? So the mass of this small volume element, so mass of this small volume element bounded, so it's actually the net force acting on this element in the z direction. What is the net force acting on this? What is the net force? Now what is the net force acting on the acting on this element in the z directions? So now the net force, so now net force acting on these element in the z directions. What is the net force? Fz plus dfz minus fz, that is equals to dfz, and that is equals to del fz upon del x is change with x, is actually it's change with the positions x. Okay, so this is the equation number 1. This is net force acting on this element z directions. Now we consider the what is the mass of this element, mass of this volume element bounded by these vertical planes. Okay, so what is the, so now the mass of this volume element bounded by the vertical plane. Okay, bounded by the vertical plane is actually density into displacement into area of the bounding planes actually. So here rho is the density of the material, dx is the positional displacement actually. There is no need to explain the this dx, you know about that. And ax is the plane area of the bounding plane, area of the bounding plane. Okay, this is the mass of the volume element bounding the vertical plane. Okay, it's okay. So in this volume element, net force acting on this volume element, okay, and the mass of this volume element we already know. This is the equation number 2. Now next go to the another case. As we know, the vertical shear. Okay, why vertical shear is actually arise? Okay, vertical shear, vertical fz arise due to the shear stress, right? This fz, why fz is this fz and fz plus dz, why this type of forces actually arise? This type of forces actually arise, we already mentioned, due to the vertical shear, right? This is due to the vertical shear, we already mentioned here, due to the vertical shear. Okay, vertical shear, and these vertical shears are parallel to the plane of the vertical plane. These are not perpendicular to the plane. If this if the shear is perpendicular, if the shear is if this the force arise due to strain or also force due to arise stress, this is the two case actually. Here the force arise due to stress. Okay, we already know when longitudinal force in the previous case propagating through a medium, then strain is arise, right? And due to these strains force acting on the element, and this element is have a displacement along x directions, along the wave propagation directions. But in the case when in a medium, longitudinal wave propagating through a medium, then this longitudinal wave produce displacement along vertical directions and also produce the force along vertical direction, and those forces are arise due to the shear, right? Shear stress. Okay. So this is the principle. So let us take a note, right? Let us take a note. This is very, very important. This is BSc level concept actually. Let us take a note. The force Fz arise from the shear stress sigma xz on the area, obviously on the area Ax. Okay. So what is the value of Fz? No, sorry. So we are sigma xz. This is the shear stress, and this shear stress is actually force acting on this area. So Fz equals to sigma xz into Ax. This is the force, and this force is arise due to this shear stress at the area Ax. Okay, at the area Ax. Okay. At now this Fz force is changed with the propagation directions, right? Change with the propagation directions. Okay, this is equation 3. So now we have the equation of motions of vertically sheared element. So what is the equation of motions of this vertically sheared element? That is very important. Now the equation of motions of vertically sheared element. What is the equation of motions of vertically sheared element? Force equals to F equals to ma according to Newton's law, right? Equals to force M equals to ma. So mass, we have already have a mass. So Fz, right? Force. What is the net force? Okay, that's okay. 1 second. Equation of motions, del Fz upon d delta x into dx, that is the force acting on this element, equals to mass of this volume element, that is equals to rho dx ax into displacement del 2 omega upon del t square. This is the accelerations, right? This is the accelerations. Okay, this is the accelerations part. So now Fz from equation 3, put here the value of Fz. So del x into sigma xz into ax into dx into rho dx ax del 2 omega upon del t square. Okay. So finally we get rho dx ax del 2 omega upon del t square, that is equals to dx ax del sigma z upon del x. So now here from these equations, dx ax is cancel each other. So we get del 2 omega upon del t square equals to 1 by rho del sigma xz upon del x. This is equation number 4. This is one general equations. Okay, now from the Lamis expressions, right? From the Lamis expressions, we have some Lamis expressions from the Lamis expression. Sigma xz is equals to 2 mu epsilon xz. Okay, epsilon xz. So here actually this is called shear stress. This is called shear strain. Okay. Okay. Now this is equation number 5. Now just it substitute it here. Now also we know the shear strains. Okay, from it just clear here the Lamis expressions, and this is the shear stress and this is the shear strains, relations between shear stress and shear strain. And now the shear strains is actually represented here. The shear strains is actually represented here is like that. Okay. This shear strain is actually represented as 1 by 2 del W upon del X plus del U upon del Z. But here no displacement of the element along Z there. Okay, मतलब डिस्प्लेसमेंट का चेंज जेड के साथ नहीं हो रहा है, एक्स के साथ चेंज हो रहा है, राइट? एक्स के साथ चेंज हो रहा है. सो this part here is actually 0. This part is actually here is 0. So we get to cancel out omega till omega upon del x sigma xz equals to mu del omega upon del x. This is equation number 6. Now from equations 4, from equations 4 we get what is the expression? Del 2 omega upon del t square 1 by rho. Okay, del x, yeah, mu del omega upon del x. So del 2 omega upon del t square mu by rho del 2 omega upon del x square. Okay. So that is equals to del 2 omega upon del t square, that is equals to beta square del 2 omega upon del x square. So this is beta is called shear wave, where beta equals to root under mu upon rho, and it is called shear wave. It is called shear wave. Okay, now this is called shear wave. Now use this expression and try to calculate the S wave velocity. Okay, try to calculate the S wave velocity. Now from this is called shear modulus. You know, mu is equals to shear modulus. Here it's actually rigidity or shear modulus. It is called actually rigidity or shear modulus. Okay. Now we have a relations between uh, let's take down up to this point. Please take note. Okay, up to this point, please take a note in carefully. In that case, it's very important. All the theories are very important for your examinations. Okay, please properly take a notes each and every points. Please properly take a notes each and every points. Okay, so this is the velocity of wave. This is a shear wave, and another is stress wave, shear wave. So this shear wave beta equals to mu by rho. Mu is called rigidity or shear modulus. Rigidity or shear modulus. So from this property, okay, that determined that the velocity of this shear wave is the rigidity of shear modulus. This is the elastic property. Shear wave is the elastic property. The only elastic property that determine the velocity of this shear wave. फ्रॉम दिस शेयर वेव, ये जो शेयर वेव है, ठीक है, इस शेयर वेव से हम लोग ओनली वन प्रॉपर्टीज़ को हम लोग डील कर सकते हैं इलास्टिसिटी का, वो एक्चुअली रिजिडिटी और शेयर मॉड्यूलस. ओके, सो दिस एक्सप्रेशंस एक्चुअली व्हाट टेल अस, that is very important. Okay, the velocity of this shear wave only determined the elastic property like the rigidity or shear modulus. This is the MSQ question. Okay, only determine this elastic properties. But in liquid or gas, rigidity modulus or shear modulus is equals to 0. So shear wave cannot propagating in a medium. So okay, from this expressions we get another concept is also. So H in liquid and gas, mu equals to 0. So hence shear wave, cannot propagate in liquid and gas. Shear wave means S wave. So S wave that cannot propagate through any liquid or gas, but P wave propagating through any mediums, liquid, gas, solid. Okay, that's 2 points. Okay. Now we have to find out, this is the S wave velocity, okay, and we already in previous class and In the previous class I discussed the what is the velocity of P wave velocity. So now let's discuss two share wave. So we have P wave velocity, and that is equals to alpha. Alpha is equals to lambda plus 2 mu upon rho, or it is equals to k plus 4 by 3 mu upon rho. This is the exact answer. So okay, you just forgot the first term, you just remember the last terms. Alpha equals to k plus 4 by 3 mu, k plus 4 by 3 mu, 4 by 3 mu by rho. Okay, mu by rho. This is the P wave velocity, and the S wave velocity, but shear wave velocity as beta is equals to mu by rho. Okay, these are the two velocity expressions. Okay. Now one thing is very important. Please take. So this is equation number 7. This is equation number 7. This is equation number 8. Okay. So from comparing between equation, now comparing equation 7 and 8. Okay, what we get? Very beautiful result, and that question is actually asked in UPSC GEOScientist examinations. Now the comparing equation 7 and equation number 8, what we get is actually, can you say? Okay, let's try to clear about that. Alpha okay, equals to k plus 4 by 3 mu upon rho. So that is equals to alpha square equals to k plus 4 by 3 mu upon rho. Okay. Yeah, so alpha square rho equals to k plus 4 by 3 mu. Okay, this is equation number 9, and also beta equals to mu upon rho. So that is equals to beta square mu upon rho. So beta square into rho equals to mu. That is equation number 10. Let's substitute the value in mu in equation 9. Now substitute equation 10 in equations 9. We get alpha square rho equals to k plus 4 by 3 beta square rho. Okay, so from these expressions we get alpha square rho minus 4 by 3 beta square rho equals to k. So alpha square minus 4 by 3 beta square into rho equals to k. That is equals to alpha square minus 4 by 3 beta square equals to K by rho. So this is the actual relationship. Okay, and K is the bulk. This is the actual relationship between P wave velocity and S wave velocity. Okay, so this is the relation between P wave velocity and S wave velocity. So these questions asked in your examinations actually. One, please establish the S wave and P wave velocity in properly. Okay, so this is the relationship between P wave velocity and S wave velocity. And K is here is the bulk modulus. Okay, K is a bulk modulus. Please remember K. This is the bulk modulus. Okay, and it is always positive. It is always, and it is positive. It is always positive. So from these expressions, this is equation number 1. So what we get from these expressions? What is the important points we get from these expressions? Okay, what is the important points we get from these expressions actually? So as K is positive, it means alpha is always greater than beta. So H, K is positive, hence alpha is greater than beta. So alpha is greater than beta. What is the meaning of that? It's meaning that the alpha, what is the alpha? Alpha is the P wave velocity. What is the beta? S wave velocity or shear wave velocity. So alpha, primary wave velocity, is always greater than the S wave velocity. So it means from an earthquake, S wave travel. Okay, so what is the meaning of that? What is the meaning of that? It means that it's a very, very important point. Please take a note. Please take a note. It's a very, very important point. I try to explain you. Shear wave means S wave from an earthquake travel more slowly than P wave. And recorded at an okay, no, there is no need to these explanations. Up to this point is very, very important. So this okay. So that's why shear wave are often referred to as a secondary wave. Or SOF. So we finally derive the P wave and S wave relationships, and from these relations we get S wave travel slowly, okay, compared to the P wave, Okay, so that are the very important points. These 2 points are very important. These 2 points are very important. I try to discuss here. Okay, try to discuss here. So please take a note in proper way. अब लोग अच्छे से एक एक पॉइंट को पॉइंट्स को नोट डाउन करिए, ठीक है, क्योंकि एक एक पॉइंट्स वेरी इंपॉर्टेंट है। यहाँ पे मैंने एक एक पॉइंट को अच्छे से डील किया। अब लोग अगर एक एक पॉइंट को अच्छे से लिखोगे ना, तो आपका कंसेप्ट ठीक से क्लियर हो जाएगा। तो मैंने पहले एस वेव का जो वेलोसिटी था, सी आर वेव का वेलोसिटी, वो कैलकुलेट किया। और नेक्स्ट फर्स्ट क्लास जो था लेक्चर वन में हम लोग पी वेलोसिटी कैलकुलेट किया था। दोनों वेलोसिटी से कंपेयर करके दोनों के बीच एक रिलेशन क्रिएट किया, और रिलेशन से हम लोग ये देखा कौन सा वेव मीडियम के थ्रू फर्स्ट वेलोसिटी लेके मूव करने वाला है, ठीक है। तो ये आपका थोड़ा बहुत कंसेप्ट भी आएगा, तो आप अच्छे से इसको डील करते रहिए और आप लोग नोट्स करते रहिए, क्योंकि ये वाला क्वेश्चन आपका यूपीएससी कंबाइंड जेएनटी मेंस का एग्जाम था 2024 में। ये वाला क्वेश्चन आया था मेंस का एग्ज़ाम में। आप चेक करके देख लीजिए, शायद ये वाला क्वेश्चन 2024 का एग्ज़ाम जो था उसमें इससे एक क्वेश्चन आया था शायद। ओके, तो मैं नेक्स्ट वीडियो स्टार्ट करने से पहले मस्ट ये वाला क्वेश्चन जो क्वेश्चंस था, उस क्वेश्चंस को हम लोग एक बार मेंशंस करेंगे आराम से, ठीक है। उस क्वेश्चंस को भी एक बार मेंशंस कर देंगे, तब जाके तुम लोगों को एक अच्छा खासा आइडिया हो जाएगा, है ना। अच्छा खासा आइडिया हो जाएगा क्या क्वेश्चन एक्चुअली था, क्या लिखना था, तो आपको आइडिया हो जाएगा, अब तो जान ही जाओगे। ओके, ठीक है, ओके, इट्स ओके, चलो बाय बाय। नेक्स्ट क्लास हम लोग फिर से मिलते हैं। ओके, थैंक यू फॉर वॉचिंग दिस वीडियो एंड प्लीज़ सब्सक्राइब माई चैनल।